Welcome once again to our channel, Moto Mouths. We are talking about things to do with cars, driving, and anything else that you encounter on the road, off-road, and more knowledge. We are here to learn and to share what we know. As usual, I'm here with Engineer Chibuka, and he's going to take us through some of the complex concepts and make them as simple as ABC. You're welcome, Mr. Chibuka.
Yes, good morning. Good afternoon, Alan. It's actually afternoon. Thank you very much for the introduction. Once again, my name is Ivan Chibuka Chiguli.
Yes, I think today you're going to tell us about automotive systems, electronic engine management. These are some of the things we, the drivers, never get into. We just purchase the car, make sure it has 4 tires and it has fuel. Yeah,
But you have been hearing their computers now. So many of you know about computers. You complain about them. There seem to be some myth, so like some kind of magic that mechanics tell you about computer. Yeah. It's good that we are going to share at least what I know, a little of what I know about engine management computers.
Yes.
So I cut you short. I was just agreeing with your earlier submission.
So the electronic engine management, does this refer to the computer systems that we now find in the cars, or what the mechanics talk about when the car is having issues?
Yes, it is true. There are computers on cars. I think there were some luxury models that had these computers even in the late 80s, but they started becoming common in the 90s. Initially, there was just one or two computers, mostly to do with the engine management. Then they rolled out computers for ABS, anti-lock brake systems. Then they introduced SRS, which is the airbags. That also has a separate computer to control it. Then they introduced electronically managed transmissions, more computers. They began with a few computers. Most manufacturers started with a few computers, but now it's very easy to find a 2024 model with between 50 to 60 different computers, believe it or not. They are tiny. They are computers, yes, but not in the normal sense of the one you know, the PC, but they work more or less the same way. The principles are the same. The jobs are different. Today, I would like to discuss the engine management one, but there are so many others, different functions. For example, right now we have computers for managing sunroof, computers for managing doors. You can find each door has a dedicated computer to manage it. On a vehicle, you may have computers that manage the ride height. You have even radios, entertainment systems now are computers in themselves. So there are so many different computers these days. There are even vehicles like the Land Cruiser Prado, and from around 2015, as early as 2015, 14, they are computers in the mirrors. Each mirror has a small computer of its own. So it is interesting what they are doing with computers, but for today, let's restrict ourselves to engine management computer. Engine management, as the name suggests, is to do with engine management, but just know that these computers work in more or less a similar fashion. It's just that the function is different. So they can even communicate, just like you have a network of computers in your office, whereby you sit on your desk on 5th floor, and then you have a printer on 3rd floor, and you can print on that printer. So cars have gone in that direction. It is true. But let's not complicate things. There is more to to these computers, but I'll just go over the engine management computer because this is a common one. Most of you have at least heard about it. I'm going to share a small presentation that I made about this. Let me know when you can view it. Can you view it now?
Yes, it's now visible.
Okay. Yeah. Like Alan has said, the topic for today is going to be engine management, basically computer control of the functions of the engine. It's mostly a requirement for lower emissions. You know, newer cars are supposed to be better for the environment, as in you are having cars that are now outputting very, very low emissions to compare to vehicles from 20, 30 years ago. And while at that, they are increasing efficiency. In fact, the engines are generally becoming smaller in capacity. The mechanical physical size of the engine is generally becoming smaller, but the engines are becoming much more powerful than what we had a few decades ago, while at the same time, they have lower emissions. For example, newer diesels with DPF, if you went to the exhaust and put your finger there and try to check for soot, you won't find soot. You'll find the exhaust pipe is actually very clean. It can be even much cleaner than my shirt on a good vehicle. Anyway, the main areas of control for the engine in the ignition timing, at what exact micro, it's down to micro, not even milli, but microsecond, the ignition for each cylinder happens. Then we have the ignition door angle, that is the control of the spark, how close it happens to top dead center. Top dead center is something we talked about briefly in a previous video. You can go back and check the video for the one that was about engines, the structure of the engines. And then management of fuel quantity is also controlled very strictly by the computer. In fact, this is what guides the emissions a lot. Then you have idle speed control for when you don't have your foot on the gas pedal. And for example, you are in traffic, and then you put extra loads, like at night, you put headlamps, and then you are running AC in hot weather. You are adding a load to the engine, but the engine computer is able to manage the fueling such that the idle does not change much. The engine actually outputs a little bit more power, but you don't even notice it. And then there are further areas of engine control, which include the exhaust gas saturation. Most cars from the mid-90s have EGR systems. Most. I've not seen a vehicle from that period up to now that doesn't have an EGR system, whether diesel or petrol. And then you have evap emissions canister purge. These ones are for managing the vapors in the fuel tank. You know, vapors from petrol and diesel or any fuel for that matter, or any hydrocarbon that's liquid, when they're emitted into the environment, when they are allowed to vaporize into the environment, they hurt the ozone layer. So that one is also controlled. That system is called evaporation emission canister purge. It's controlled by the engine computer. It's mostly on petrol because petrol is more volatile than diesel. And then you have also valve timing, a topic I think I will discuss in future. And then inlet manifold length. This is very common. They started with the petrols, especially the V6s and V8s, which is to do with elongating and shortening the path of air before it gets into the engine. But those systems are also becoming common in diesels. And then the closed loop lambda control, that's the oxygen sensor that I will discuss in a few minutes. Essentially, like all computer systems, you have the computer itself. In the middle here, it is the control. I think you can see my cursor. Can you see it, Alan?
Yes, I can.
Yeah. And then the computer has outputs, it commands, but it bases its commands on the inputs it is receiving. And then once it commands these outputs to do certain things, for many systems, for example, the EGR system, you have a computer controlling the EGR valve. The EGR valve in this case is an output, but there is a position sensor on the EGR system, on the EGR, on the opposite side of the EGR valve, which checks to see if the EGR valve has actually moved like the computer commanded. And because there is a sensor for checking that the valve has done what it was commanded to do, there is a loop of input. That's why you see this kind of loop going around. The computer is in control, but it depends on inputs to make decisions, and then it sends outputs, and those outputs determine the next step. There are so many sensors, as we shall see on a modern engine, so many. That's why sometimes it's confusing, even for the people who are trying to repair these cars, even for the mechanics who are trying to repair these cars. Sometimes it is hard to keep up with all the technologies that are coming. In fact, I know people who have been cursing engine computers and sensors because if the computer doesn't get the right inputs, it may make what somebody would call a bad decision, or it might malfunction. But remember, with computers, garbage in, garbage out. So if there are problems with the inputs, there are going to be problems with the outputs. So people can be frustrated with this, especially if they have little to no knowledge of how these systems work. That's why at Moto Mouths Uganda, we've come to chat to you a little bit about this. Now, here is an engine fuel management example. You have here in the middle is a computer. It will have the engine speed, typically from a crankshaft position sensor, but also sometimes from what they call the camshaft position sensor. I'm sure you've heard about them. I'm sure you've had a mechanic telling you jargon like that. And then you also have the engine load. That one is usually from the MAP sensor, the manifold absolute pressure sensor, in short, MAP sensor. It's usually the one used for calculation of the engine load in combination with the throttle position or the accelerator pedal position sensor. Then we have the coolant temperature sensor, which tells the computer at what temperature the engine is running. That's very, very important throughout the loop for engine operation, because the computer needs to know when it is very cold, it needs to enrich the mixture so that the engine can start much easier. When it warms up, it needs to reduce the length for which the injectors are open, and therefore cut fuel and so many other things. For example, EGR operation is also restricted depending on the temperature, the charging. We have smart alternators these days on vehicles. Those smart charging systems may also depend on the temperature of the engine, the air conditioning, also so many things that the computer uses the data from the coolant temperature sensor for. And then you have the throttle position, which is the angle of the throttle. And this also guides how much air is entering and how much power you can get out of the engine. So it's quite important that the computer knows where the throttle is at any one moment. And then you have the exhaust gas O2 content, aka oxygen sensor, lambda sensor. It has a few names, but basically most people call it the oxygen sensor. So the computer needs to know the oxygen sensor is typically in the exhaust system, in the exhaust pipe. So the computer needs to know how much oxygen is in the exhaust, and it is able to determine how efficiently the engine is running. And then you have battery voltage. Again, there are sensors these days on the electrical system of the vehicle to tell the computer at what battery voltage the vehicle, the entire electrical system is operating. Mark you, with these new vehicles, the computer, without your knowledge, can suspend, for example, charging from the alternator. For example, when you accelerate very hard, it may temporarily suspend operation of the air conditioning compressor, the alternator, all those mechanical systems which are taking power from the engine. It may suspend them until you get through the hard acceleration phase, and then it restores them. And then it can even guide the computer can decide, I want exactly 13 volts charging voltage, and then it will command the alternator accordingly. So that is why they have all these sensors. Everything you see on a vehicle, everything that is electrical you see on a vehicle that came from the factory, not the word factory, not the aftermarket. Sometimes I sometimes call it junk that people add on the vehicles once they leave the dealer. Everything that the vehicle comes with from the factory has been thought through by the manufacturer. Don't mess with it. Mechanics, I know a lot of people cut wires, aka doing electrical magic. There is no magic. You are simply ruining somebody's vehicle. And if you're a customer and you have a mechanic that is doing all this nonsense on your car, please don't go to them. In some countries, you can be sued for cutting or disabling systems. Yeah, it's not a good thing. Just know that the manufacturer thought through everything. If the manufacturer wants to make the car at the cheapest price, so they do not add anything that does not serve any purpose. So if you think you are very smart and you want to disable electrical systems on a vehicle, I think it is better and easier that you make your own vehicle. If you cannot claim to be so smart at disabling systems on somebody else's vehicle when you yourself can't make or manufacture a vehicle that will operate on the road legally. So I emphasize this because I know a lot of people have run into problems. I've been involved in vehicle diagnostics for many years, and most of the vehicles that I have dealt with have come with damage created by previous garages. Now, here are some components, some typical components from an electronically managed engine system. Let's choose, for example, in the corner up here on the right hand side at the top, that is an ignition pack. You have a sensor there that looks like a cam or crank position sensor. These two look like oxygen sensors. Down here, you have injectors, there are four. So this must be a four-cylinder system. These look like position sensors, as in throttle position or accelerator pedal position. They can, for vehicles that change ride height as you are driving, they typically have position sensors. They may look similar to this, the sensors themselves, although they may have other attachments that allow them to do the measurement, the linear measurement of the ride height. This is a fuel filter. You have a mass airflow here, which is the computer uses for calculating how much air is rushing into the engine. And then you have a MAP sensor here, manifold absolute pressure sensor. But just know that most sensors that measure air pressure and sometimes even pressure from liquid like fuel pressure, they work the same way and may look similar. It's just different ranges of their measurement and also the position where they are placed that is different. At the bottom here, in the middle, you have the computer, and then here you have the ignition spark plugs. Most of you are familiar with these. So you saw here the ignition coil has 4. This means this pack has 4 coils. So each coil will fire one of these spark plugs. Yeah, this is a fuel pump up here, top on the left. Yeah, there are many other items you find in a vehicle, but I just wanted to show you this so that you start to get familiar. Once you open the engine room on your vehicle, you can go right now and open it and get familiar with some of the things so that you do not appear like you're listening to Greek when your mechanic is talking to you. Now, here is a schematic, of course, not to scale, of the same components that I've just shown you here. These are real images, but here is a schematic that shows you some of these components. For example, you have the lambda sensor here. The air is flowing from this side. Is flowing from the left to the right. It enters through the mass airflow, so the computer knows how much air is flowing in, and then based on that knowledge, it commands the injectors to release the right amount of fuel to get. Remember, last time I talked about the ratio of 1 to 14.7 as ideal. So the computer wants to maintain a certain ratio of air-fuel mixture. So it needs to know how much air is coming into the engine at any 1 millisecond. These calculations go on very fast. That's why you, as a driver, you may not notice that the engine operation is so smooth. It's because the computer is very fast in doing all these calculations. So anyway, the air will enter like this via this throttle, which will create vacuum. This is the intake manifold area. This is under vacuum on a petrol engine. On a diesel, this throttle will normally be open when the engine is running, so there is no vacuum. And then the air will come here, and this is an injector which will throw in fuel just before the air enters the cylinder, and then magic will happen inside here, something that we've discussed in the past. Then the exhaust gases will get out, and the oxygen sensor will measure the oxygen levels left in the cylinder. Then you have, by the way, normally you have 2 lambda sensors, 2 oxygen sensors. There is this one before the catalytic converter. This is the catalytic converter, aka Kasani. Most of these are stolen these days, I think, because of the metals that they contain. But after the Kasani, after the catalytic converter, there is another oxygen sensor. Now, between these, the readings of these 2 oxygen sensors, the computer can tell how well the catalytic converter is working, and then adjust the fuel injection accordingly. Yeah, there are some other components that I have not touched, but you can keep checking our other videos. I just don't want to make this video much longer. And then this final slide is about closed loop lambda control. That is something I mentioned a little earlier about, which is lambda control is basically the oxygen sensor. That is what it typically looks like inside. It's typically installed. This part here will be outside the exhaust pipe, but this part here, the sensing part, will be inside the exhaust pipe. And of course, the exhaust stream is usually very hot. So you have a lot of stuff going on there, reactions going on there. But in the end, what you get is an electrical signal that is sent back to the computer to indicate to the computer how much oxygen is left in the exhaust gases. The computer knows that the car is ingesting fresh air, so it knows the fresh air contains 20.9. So if there is, say, 15.7% of oxygen left, it knows how much oxygen has been used up in the combustion process. It knows how much fuel it commanded, and it also knows how much air went in because of the mass airflow sensor. So it can calculate how efficiently the combustion process is going and then adjust the fuel mixture accordingly. Thank you very much. That's the end of the slide. I think I can stop sharing, and then if you have any questions, you can let me know. I know we have about 8 minutes left.
Yes, and in those 8 minutes, I would like you to tell us more about that component that is usually stolen, the catalytic converter.
Yes.
And
Okay,
the whole mechanics tampering with computer systems that they themselves did not set up.
Okay. Catalytic converter. Now, like the name suggests, it has catalysts inside. They are precious metals inside. There is magic that is going on inside there. The exhaust fumes, as they are coming from the engine, have a lot of carbon monoxide, which is poisonous. Yeah, have a lot of carbon monoxide, some unburnt fuel, and then nitrogen oxide. There is a lot of chemistry that goes on there, but essentially, at those hot temperatures, with those catalysts in the exhaust stream now placed in the path of the exhaust gases, at the end of it, you have reduced oxides of nitrogen and carbon monoxide, and even less oxygen. But now the oxygen has been used up the more oxygen has been used up than what left the engine exhaust valve. What has been happening is that more oxygen has been used up to generate less toxic components. For example, the carbon monoxide has been removed, probably turned into CO2. Remember, carbon monoxide is CO. So if you end up with CO2 and probably water, you won't believe it, but moisture comes out of the exhaust pipe. It's just that it is too hot, you will not see it. But you have CO2 coming. CO2 is less poisonous than CO. And then you also have less oxides of nitrogen. So essentially, I cannot go into the details here. I cannot go into the full discussion, but the catalytic converter helps to turn those fumes using catalysts to turn those fumes into less poisonous gases. That is the whole idea about it. So when you remove it from your vehicle, or if somebody steals it from your vehicle, they are just now getting your vehicle to start polluting the environment even more. Even when the system is working properly, they are always, with internal combustion engine, there is always pollution coming out of the tailpipe. So when you remove the catalytic converter, the car is just going now to be, I don't know, it's like how you you collect garbage and you dump it.
Or,
You
or maybe
you dump it
walking
by the
without a
road. You dump it by the roadside. That in itself is bad. But when you go ahead, you don't only dump it, but you even throw it around on the road, or maybe some dogs come and they spread that rubbish around. That's even worse. That's even worse. So you have pollution coming out of internal combustion engines, but there are systems that have been fitted to try to manage that. So when you remove those systems, it is just now pollution galore. There's absolutely, you are just ruining your environment. It's your environment too. Whoever is doing it, it's not only for, it's not for
the car owner.
it's not for the car owner or the people living where you are passing. It's for all of us. It catches up with us. I don't know how to put that better. Maybe we shall have a topic one day to discuss about emissions. I know it is these emission control systems are frustrating for a lot of owners and mechanics, but they have been fitted on those vehicles for very, very good reason. Don't try to tamper with them or try to to remove them. Don't try to bypass them. In some countries, in Uganda, maybe it's not yet law, but in some countries it is very legal. You can actually be jailed for, for playing with those systems. Now, your other question was about the other systems that are tampered with, electrical systems, for example. Yeah, mechanics tamper with them. I'll give an example of removing a thermostat. When you remove a thermostat, your engine is going to, if the car is overheating, get a mechanic who can find out the exact reason for the engine overheating. Simply removing a thermostat is a lazy way of trying to fix that problem. When you remove the thermostat, most time the engine is going to run at a temperature 20 or 30 degrees below the normal operating temperature. And the computer is going to respond. Remember, it has a temperature sensor on the engine block. It is going to respond by fueling a little bit more. Remember, we say the warmer the engine gets, the less fuel the computer commands. So when you force the engine to go cold or colder than it normally should operate at, you are forcing the computer to dish out more fuel. So it is going to cost you money, and it is also going to pollute the environment some more. In countries in the Middle East, where it's very hot, vehicles have thermostats. How come they are able to operate there? And you are saying Uganda is warm, but it is not the hottest place on earth. So, yeah, when you remove such things, the computer may be able to keep the engine running, but it will be rather inefficient, and it may not be very good for our environment. So, another example is when mechanics remove some sensors like the oxygen sensor. I have many customers that come with such issues. Usually what happens with the oxygen sensor removal, the car defaults into open loop cycle all the time. That's another story, but what happens is the computer errors on the side of caution, it just dishes out extra fuel. So over a long journey of 200 kilometers, for example, it may cost you 17% more fuel with the engine operating like that. Now, it's not good for your wallet either. So we need to get competent people to fix these vehicles and get them to operate the way they should, not to try to do Juwakali kind of work on them. This is a wide topic. It's not something I can cover now with the few minutes we have left. Probably we shall have to discuss it in another video.
So lastly on that one, if I have my car and it has sensors are there, then I take it to garage and they remove them. Now my car is more fuel. Isn't that grounds for me to sue the garage owners in case I can prove that it had the sensor before?
Yes.
Now it has been removed and my car is consuming more fuel, and even my life is in danger because the car has been tampered with. Because
you are very right. You are very right. If you
can stop this doing such things.
Yes, you are very right about that. However, you have to prove that they were removed without your knowledge, because sometimes what happens is the mechanic will tell you and you agree because you want to get back on the road. But if you can prove that a component has been removed from your vehicle, yeah, you can sue these guys. That's what happens in developed economies. I think we've run out of time. Thank you very much for hosting me this time.
You're welcome.
Thank you.